All right, so this lesson is solving systems of equations by graphing, and we're going to go through these notes together, and then you will have some practice to do on your own afterwards. So we're going to start by talking about what systems of equations are. And a system of equation is two or more equations that have the same variables. In our case, we're going to be dealing with equations that have x and y. And when we talk about the solution to a system, it's the point where these two lines intersect. And when we're doing this algebraically, which we will do next week, it's the point or the x value and the y value that are going to make both equations true. So this one point, xy, is going to be the exact same point for both lines. And we'll see what that looks like graphically today, and we'll see what it looks like algebraically next week. So there's three different types of solutions we could see graphically. We could see lines that intersect, and they will have only one solution. It will be the point x, y. So whatever these coordinates are right here for x and y is what I would write as my solution. We could see lines that are parallel, and we know that if lines are parallel, they have no point of intersection. That means there will be no solution. You could see that written as NS, NA, but typically, especially if it's a multiple choice question, you will see it written as no solution. And then lastly, they could just be the same line. So you'll notice I did two different colors here. So I tried to make it as visible as possible. There's the turquoise line in the middle and the purple line right underneath it. They are the exact same line. That is infinite solutions because every single point for both lines is exactly the same. So when we're solving by graphing, what we're going to do first, and I'm sorry I didn't give you a ton of room in here. If it's possible to graph it in the form that's given, we're going to do that first. So whether it be standard form with my x and y intercepts, slope intercept form, or point slope form, we're going to try to just graph the line in the given form that we have. If for some reason we get intercepts that are fractions from standard form, we're going to take that equation and rewrite it in slope intercept form and then graph it. And regardless of whether you could do method 1 or method 2, ultimately our answer is going to be identifying the solution. So I'm going to do this in two different colors so that you can see these graphs clearly. So you'll see graph number 1 and you'll see the first equation and the second equation clearly graphed in different colors. We are not going to do every single example. We are going to do most of them, but we're not going to do all 8. So let's start with number 1. So I'm going to do my first graph in blue. This is in slope intercept form already. So my intercept is the constant. This goes all the way back to unit 2. So I'm going to go down to -8. I'm going to put a point there. So here our b value is -8. and our m value, or our slope, is 1. So then from that point, since it's positive, it's going to go in this direction, up 1 over 1. And I'm just going to put a couple on each side. It would be helpful to have my ruler handy, which I do not. And now we're going to connect the dots. So there's our first graph. I'm going to do my second graph in purple. My B value is 1. So I'm going to put a 1 there. My M value is -2, which is technically -2 over 1. Since the slope is negative, it's going in the opposite direction. So from here, I'm going down 2 and over 1. And you'll notice a purple dot just landed on top of a blue dot. That is not a coincidence. That is my solution point. So that point is 1, 2, 3 for x, 1, 2, 3, 4, -5 for y. So that's my solution. I'm actually going to get a different pen that dries a little bit faster. Switching over to blue and pink. All right. So moving on to number 2, both of these again are in slope intercept. I'm going to do this first one in pink. So my B value is 9. My M value, or my slope, is 1/2. It's positive, so it's going this way. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Let me just double check. 4, 5, 6, 7, 8, 9. Okay, yep. And then down 1 and over 2. Or up 1 and to the right 2. And I'm gonna, nope, not do a very good job connecting these apparently. Now you do have to be super careful with how you draw your lines. All of my sloppy line tracers out there, get yourself a ruler or a straight edge. You have to be extra super careful and precise with these. And just in case you haven't noticed, I'm not using Desmos. This is all calculator inactive, just FYI. So for our second equation, our B value is 6, and our M value is -1. So 1, 2, 3, 4, 5, 6. And then I'm going to go with a negative slope. And you'll notice I've already had a blue dot cross over a pink dot. There is my solution, which is -2 for x, and then 1, 2, 3, 4, 5, 6, 7, 8 for y. All right, switching over to the next page. I'm going to zoom this in a little bit. All right, so here with number 3, let's start with the second one. Sorry, I just still have blue in my hand. I didn't feel like switching. So in this case, These are both in standard form. When I look at my second equation, I'm looking at negative x plus y equals negative 2. When I look at that equation, if I substitute 0 for x, I would have 0 plus y equals negative 2. That tells me my y-intercept is negative 2. I can put that point here. I'm going to do the same thing and substitute in 0 for y. Negative x plus 0 equals negative 2. You have to be incredibly careful because this says negative x equals negative 2. Dividing both of those by negative 1 tells me that x equals 2. Since both of those are whole number tick marks, I am okay to use standard form for the second equation. Now, if these 2 points are really close together, another thing I can do is look at how I'm changing from this point to that point. That's up 2 over 2. I can repeat that pattern to get myself a little bit more of a line. And you'll notice I have created a line that has a consistent slope. Now I can connect these points, and that is my blue line. Now, if we do the same thing for our first equation, it's not that big of a deal when I substitute 0 in for x, because 3 times 0 gives me 0. So that tells me my y-intercept is 8. Well, that's all well and fine. 1, 2, 3, 4, 5, 6, 7, 8. The issue is, if I do the same thing with y, I'm not going to have y here, and I'm going to have negative 3x equals 8. I can't have 8/3 graphed. That's not going to work, friends. So I have to take this first equation and I have to rewrite it in slope-intercept form. So I'm going to have y equals 3x plus 8, and I'm going to use my slope, which is 3, which really is 3 over 1. So I'm going to go down 3 and over 1. And look at that. We have found our point. Let's switch back over to blue. It just shows up better. So that's 1, 2, 3, 4, 5 in the negative direction for x. 1, 2, 3, 4, 5, 6, 7 in the negative direction for y. So that solution would be negative 5, negative 7. All right, moving on to number 4. X plus 2y equals 4. That is standard form. Now, if I look quickly at the coefficients for x and y, if they are both evenly divisible into 4, I am good. Does 1 divide 4 evenly? Yes, it does. Does 2 divide 4 evenly? Yes, it does. That means I can substitute 0 in for x, and I'll get a whole number for y. This would be y equals 2. So I'm going to go up to where y is 2 and put a dot for that intercept. And I could do the same thing and keep x. Take out y and put a 0. X is 4. 1, 2, 3, 4. Now again, like we did on the last one, those are still pretty close together. So down 2 over 1, 2, 3, 4. I'm at least going to put 2 more dots. 1, 2, 1, 2, 3, 4. I would rather be safe than sorry. My goal is to be precise in my mathematics. That's one of my mathematical practices, is attending to precision. So I have to make sure I'm being as precise as possible with these graphs. The neater you are, the better. All right, looking at my second equation, it is slope-intercept form. So B is 2, our slope is -1/2. Oh, look, I already have my overlap. Now I am still going to keep going. Down 1 over 2. Oh, wait, look, there's another point of overlap. Down 1 over 2. Oh, wait, there's another point of overlap. Down 1 over 2. Oh my gosh, every single point is overlapping with my pink line. Up 1 over 2, up 1 over 2, up 1 over 2. Everything is overlapping. That means these are the same line. And if they are the same line, we have infinite solutions. All right, we're going to do number 5. We'll probably do 2, maybe 3 more. All right, so the first one, x equals 3y minus 15. Now, if I take out y and I replace it with 0, that would be x equals -15. I probably need to double check that I even have room on this graph we've been given. 1, 2, 3, 4, x. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I don't have room to get to -15. That tells me I'm going to have to rewrite my first equation in slope-intercept form because I just don't have enough room to graph it. So I'm going to rewrite it. X plus 3y equals -15. I'm going to subtract x. 3y equals -x minus 15. Divide by 3. Y equals -1/3 x minus 5. So B is -5, and our slope is -1/3. So my line's going to go this way. So down to -5 for my y-intercept. And I'm going to go down 1 over 3. Or up 1, and in the other direction, 3. Okay. So there is our pink line. Now with our second equation, y being equal to -7, that's a horizontal line. Anytime I see y equals a number, it is horizontal. Down to 7, This was 5, 6, 7. So that tells me this line is going this way, and there's my intersection point. Now, I already know the y value because it says so right here. I just need to find x, which would be 1, 2, 3, 4, 5, 6. So the point there is 6, negative 7. All right, we're going to do number 7, and then we're going to look at number 8, and then we will be done. And the reason I want to talk about number 7 really quick is only because number 7, you do not have to turn into slope-intercept form. I'm going to show you why. Actually, that's not true. You do have to turn it into slope-intercept form. Sorry. Because 35 divided by, or negative 35 divided by 5 is negative 7. That would fit. 35 is not evenly divisible by 3. So I can't use standard form. I have to use slope-intercept form. So subtract 3x. Negative 5y is negative 3. Oops. Well, I'll change that in a second. Negative 3x minus 35. And I'm dividing by negative 5. Just pretend that this actually looks like a negative 5. Everything is fine. All right. So the slope-intercept form here is y equals positive 3 over 5x plus, is it positive or negative? It's positive because I got a negative divided by a negative, and it's going to be plus 7 because 35 divided by 5 is 7. So my b value is 7. My slope is 3/5. 1, 2, 3, 4, 5, 6, 7, and then up 3, 1, 2, 3, 4, 5 over, or vice versa. Gonna do one more. There we go. So connecting these. All right, now with the second one, I do not have to put this in slope-intercept form because if I replace x with 0, I get negative 6. That I can graph. 1, 2, 3, 4, 5, 6. And then taking out x, I'll have 2x plus 0 equals negative 6. So that tells me that 2x is negative 6, so x is negative 3. 1, 2, 3. Now, yeah, these are kind of far apart, but should probably put one more point on there just to be safe. So this is 1, 2, 3, 4, 5, 6 over 1, 2, 3. 1, 2, 3, 4, 5, 6 over 1, 2, 3. And if we connect these dots, you'll see that we do go through this point right here. Now, why did that not show up when I did my slope with the blue line? Well, oops, sorry, accidentally smacked the 6/3, so I went up 6 over 3, so my slope is 6 over 3. That's the same as 2. So I should also be able to go up 2 and over 1. So up 2 over 1, up 2 over 1. And that's just further proof that that is our intersection point. So let's see. 1, 2, 3, 4, 5 in the negative direction for x. 1, 2, 3, 4 in the positive direction for y. And the only thing I'm going to do with you with number 8 is talk about this right here. This is a vertical line. So I would go to where x is -2, and I would have a vertical line here, like so. And then it's your mission to determine, can I leave this in standard form and get my x and y intercepts, or do I need to do slope-intercept form?